Okay, guys, if you were struggling with writing or identifying the standard form equalities with its fractional form, then you need to send me a remind so that we can either get on a Google Meet and work one-on-one, or you need to write down your question and ask when we're face-to-face in class so that we can work some problems on the board. If you're good, go ahead and move on, and we're going to look at being able to write both in the standard form and the fractional form when working with conversion factors. Being able to easily understand and convert between both forms will help you when we get into the problem-solving portion of dimensional analysis. So, standard form is your equality statement. One thing equals another. The fractional form is when you set up your values from the equality into either the numerator or the denominator. Now, I'm going to write them both ways, but you're going to see later on when we start setting up the problem that only one of the fraction forms are going to actually work to be able to cancel out your units. All right, so let's look here at our first equality. So the equality statement says that 1 meter equals 100 centimeters. So what the statement says is that for every 1 meter, there is inside of it 100 centimeters. You could also say it backwards, that for every 100 centimeters, it equals 1 meter. Okay, they mean the same thing. So I can take that equality and I want to be able to set it up in its fractional form. So I could write it as 1 meter in the numerator over 100 centimeters in the denominator. Okay, I could represent it in its inverse form with 100 centimeters, and I'm going to use its abbreviated form just because I'm running out of room on the slide, over 1 meter. Okay, both of those fractions mean the same thing, and they represent the equality statement that 1 meter is equal to 100 centimeters. All right, let's look at the next one. So we already have 1 in fractional form, 1 foot over 3 yards. So what does that mean? Well, it means that for every 1 foot, you have inside of it 3 yards. Okay? I could write it the other way. It means the same thing. I could have written 3 yards is equal to 1 foot. Okay? They mean the same thing. Now, I could also write this fraction with the 3 yards as my numerator and the 1 foot as my denominator. And you're going to see why that's really important, why you can use the inverse of the fractional form, because one of these is going to be used to solve the problem, depending on what units you're going into and out of. And I'll get to that later.